Welcome, friends, to the show that helps you spend. This is the Occasional Podcast, Season 13, Episode 4. So far this season, we've covered turntables, we've covered analog versus digital, we've had an interview with Peter Letterman of Soundsmith, so we've got some great heritage legacy style interviews in. I love those to help capture the moment, what's going on. I wanted to bring it back to a more educational beat on this episode. We wanted to have some of our technical experts, Ed and Nick from SVS, on the show. So I'm happy to bring you that this week. Also, things have been kicking off in terms of the product launch cycle for the holiday season, something that we always look forward to. I'll be the first to admit that with my conversations with manufacturers, this season 2025 has been a little bit slower than usual, but there's still a lot of great products coming out, and we'll keep you ahead of the curve in terms of all that stuff. We have a bunch of shows coming up, Capital Audio Fest. Also, we went to Audio Vision SF this week and kind of heard their stuff that they got going on in San Francisco. So we plan to keep everybody informed in that way. But the subject of today's educational romp, you might say, rooms, room treatments, room correction, bass, and what you can do to fix it all.
Direction, control the flow, otherwise it goes. No one knows. Direction, control the flow, otherwise it goes. No one knows. Chasing waves.
So we also tapped into AI this week to ask the proverbial question, what if Hunter S. Thompson wrote something about audio? And this is what he churned out. I will leave you with this before we jump right into the interview. The audiophile world is a boutique inferno of rare metals, fluctuating frequencies, and imported adjectives. There's also the occasional song. Let's go. Today's episode is brought to you by Pass Labs. For over 3 decades, Pass Labs has delivered unparalleled sound quality. Solid-state amplifiers designed by legendary engineer Nelson Pass and preamplifiers designed by Wayne Colburn come together to bring warmth and transparency to your audio experience. Handcrafted with precision and passion in the U.S., our world-class service department is here to ensure your Pass Labs products bring you joy for years to come. Listen with Pass Labs and discover your music like never before. For nearly a century, Wharfedale has defined what we know as the British sound: natural, musical, and unfatiguing. The new Evo 5 carries that tradition forward with modern refinements. Air motion transformer tweeters for effortless treble detail, woven drivers for rich mid-range and bass, and gracefully curved cabinets designed to minimize resonance and enhance imaging. What makes Wharfedale special isn't just the engineering, it's the philosophy. Evo 5 delivers performance you'd expect from far more expensive loudspeakers, staying true to Wharfedale's belief that great sound should be within reach of every music lover. Heritage, craftsmanship, and true value for the money. That's the Wharfedale way. Discover the new Evo 5 series at wharfedaleusa.com. Today's show is brought to you by The Voice That Is. Doug White is an award-winning boutique dealer that has assembled a refined selection of elite brands, featuring Tidal Audio, Doman Audio, acoustical systems, REL subwoofers, Siltec cables, Turnball cables, Vinnie Rossi, and the fabulous Tidal by Bugatti components, just to name a few. Providing personal service, TVTI's carefully selected brands are from the finest companies in the world, each of which at the top of their category and represents exceptional high quality, performance, and above all, musicality. Check out a full list of all of Doug's world-class products at www.thevoicethatis.com. And if you are attending Capital Audio Fest November 14th through the 16th, stop by and see Doug in the Wilson Room to hear several new products in person. He will be happy to see you. Hey everybody, thank you so much for joining us. I'm overwhelmed. If you guys listen to the Conan O'Brien podcast, they always have their guests say something, and they always say something funny. But I'm overwhelmed with joy, let's just say, because today I have two of my favorite cats on the show, Nick Brown from SES and Ed Mullen from SVS. How are you both doing today?
Doing well, Brian. This is Ed Mullen.
Brian, it's always great to be here. This is Nick with SVS. I'm the VP of Marketing, and we could not be more excited to be chatting with you today.
So the guys have been on the show a couple times before, but Ed is one of the most knowledgeable guys that I run into in the business on a wide variety of topics. And Nick has a lot of stuff cooking in the oven as well, so I wanted to have them both on so I could lay some information. But one of the main things that kind of came out of my conversation with Nick and Ed was room treatments. And this is a topic that is very hotly talked about that we haven't discussed on the podcast too many times. But first, before we get into that, we do want to talk about some upcoming events that are coming up. Nick and Ed, they run an amazing live stream that you guys should check out. Nick, why don't you tell us a little bit more about the live stream, what you have going on?
Yeah, absolutely, Brian. We started the Audiophile Happy Hour during COVID times because we do a lot of dealer events, in-person events, and obviously we were not able to do those. So we started this live stream, which was really about just answering questions from our community. We've had special guests from the world of Hollywood audio mixing and mastering, as well as musical artists, things like that. Even professional athletes who are audiophiles, and it's just a great way to kind of engage our passion, but also provide some technical knowledge, answer some questions live, and it's really been awesome. So we typically do them Wednesdays from 6 to 7 Eastern, once or twice a month, as well as do live streams from some of our dealer events as well, of which we have a few coming up, the next being November 4th at Apt Electronics just outside Chicago. And then I would be remiss if I didn't mention Capital Audio Fest, which will also be doing a live stream from there, and have two rooms set up, a 2-channel room featuring our Ultra Evolution Pinnacle flagship towers, and then a multi-channel Dolby Atmos music room where we'll be doing some home theater as well. But we're actually jumping in there with Orchard Audio to do the front-end electronics, and that's going to be an incredible experience with Dolby Atmos music and a multi-channel experience that I think people will really enjoy.
Yeah, you'll catch me there. I will be at Capital Audio Fest as well. Thanks for that update, Nick. And I wanted just to say, before we move on to the subject at hand, is that a lot of companies tried to do the live stream thing during COVID, and I just feel like yours came out at the top of the heap. It was this really successful thing. The amount of people that tune in is incredible, and you kept it going. So I want to just say kudos to you for kind of taking something that everyone was really attempting to do and making it actually work. So good on you.
I appreciate that, Brian. Just one thing I'll say, we do giveaways, which doesn't hurt with the attendance, but also we always said to ourselves, these are not going to be infomercials. They're not going to be like all SVS, shoving it down your throat. They're very much topical and trying to provide, resourceful information, as well as, talking to people who are just passionate about great sound. So I appreciate you saying that.
Yeah, it's a good time. It's a fun listen. I really have enjoyed my time. I poked my head in there a couple of times. No wins on my end yet, though, in terms of the giveaways, but I keep trying.
Keep trying. all you got to do is enter once.
In my experience, I've had the opportunity to live in a bunch of different places. I've moved around quite a bit. I lived in some really great cities, and I've lived in some really great spaces. But since I've been doing this, I have had the opportunity to listen in a bunch of different rooms. Now, one of the big clickbait things that goes on today is this little catchphrase or hot phrase that people say is hey, you think this speaker makes a difference? It means nothing unless you think about the room. Oh, this speaker better than this speaker? Did you do your room first? This is really something that we've been hammering home for the past 10 years, is that before you quibble over the nuance of a speaker, make sure you have your ducks in order. Make sure your room sounds the best it can. And this is why it's important to talk about today. And I will say this from my experience, there are extremes, right? On one hand, how much does the room matter? It can matter greatly. Sometimes it doesn't matter as much. We're going to get into some of that detail today. But from my experience, where it starts is I lived in an apartment that was on the 40th floor of this thing, and it was mainly glass. It was the worst room to listen to. So I'm going to start with that extreme. If you have a room that has tons of hard surfaces, and you sit there and it sounds like you're in an echo chamber, that's bad. Okay, so this is where you might want to start to take some steps. If you're in your room and you do the hand clap thing, which I think most of the guys know, but if you clap your hands and the the resonance, the reverb we call it in the studio that follows it isn't so bad. Maybe you don't need to do as much. And when it comes to bass, so SVS makes subwoofers. There's a lot more nuance to even that, but that's where you can begin. And I'll just say, when you living in a goldfish bowl like I did, it was really hard to hear the speakers because of all the sound rays hitting my ears. On the other hand, I had a guy come over and say, man, it sounds really good in this room because when he sings, he heard this delayed reverb. So the idea can be confusing, but we're going to try to simplify that out and kind of like get into the nuts and bolts of it. With that being said, I wanted to move on to the other extreme where, as we talk about moving some of those rogue sound rays out, there is an argument that too much can be a thing. I'm sure you have all heard the myth that if you are in an anechoic chamber with no reflections, that you go crazy. I think that's a little bit overhyped. I don't know if that's necessarily even true, but I will say this. Some dealers I go into, they try not to go too deep on that because they feel like the room becomes lifeless. There's like too much. But in between these two extremes that we have, way too much reverb and absolutely completely anechoic chamber, we have where you'll probably live. Ed, what do you think are the most common kind of things that start in between those two extremes? I mean, maybe let's start with, what do you do in the far extreme? You go into your room, there's just echoes, reverberation everywhere. What would you do in that scenario?
It's interesting you bring that up because I've always noticed. Have you ever climbed a stairwell in a subway or a train station, and you're having a conversation with someone who's ahead of you, and you're climbing the stairs, and it is literally the worst kind of echo chamber in existence, and you cannot understand what that person's saying, and the reason why is the direct to reflected sound ratio is so high that the voices become unintelligible. So that's sort of the worst case situation in a room. The room's completely untreated. There's a lot of bare reflective surfaces. It's an echo chamber, as you said. It's a very apt term. And it just completely wrecks the soundstage, the imaging, the ambiance in the room. And I'm a big fan of room treatments when you can do them without really disrupting sort of lifestyle considerations like visual impact and decor integration. That does matter to people, but if you have a little bit of freedom in being able to install basic room treatments, it can transform the sound quality of the room. And I tend to break them down into three fundamental areas. The first one is acoustic panels and treating primary reflection points. The primary reflection points are the ones that are going to bounce off the ceiling and the walls and then reach the listening position sometime after the direct sound coming out of the speaker. And it's those secondary reflections that tend to smear the sound stage and reduce dialogue intelligibility and our ability to perceive nuance and detail. But as you said, Brian, if you over-treat the room with sound treatments, with sound panels, you start to lose what I consider to be an optimal direct-to-reflected sound ratio. And the direct-to-reflected sound ratio lets you know what size room you're in. If you've ever walked into a large auditorium, even with your eyes closed, you know you're in a big room. Why? Well, you're listening to a very different direct to reflected sound ratio and the amount of time it takes for those reflections to reach your ears. So your brain processes this and you say to yourself, wow, I'm in a big open auditorium. Or if you walk into a really small untreated room, it's an echo chamber, the clap echo and reverb is high, and your brain says, I'm in a tiny echo chamber. I really don't like the way this sounds. So the sound panels really should be used to treat primary reflection points, but not to over-treat the room and lose some of that reflected sound. We need reflected sound in the correct ratio. So that brings me to the next one, which I just call diffusers. Diffusers will scatter mids and highs without absorbing them. So you're sort of you're preserving that some of that acoustic energy in the room, but when you scatter it, you avoid it coming back to the listening position in a manner which ruins the sound stage and the detail and the nuance and the dialogue intelligibility. Instead, it comes back to the ears in a very diffuse way, and so you preserve the mids and highs. You diffuse and scatter the reflections. You still get the reflected energy and the optimal ratio of direct reflected sound, but the sound stage is preserved. In my reference theater, I have quite a few diffusers strategically placed. The room actually sounds larger than it is. If you sat there and closed your eyes, you'd swear you're in a room twice as big, and that's because of the way I've tuned the room for direct reflected energy ratio, and also the diffusers are just scattering the sound, and with your eyes closed, you're like, wow, this is a pretty big room I'm in. And that brings me to the last one, which is bass, right? So bass traps are the sort of the third leg of the bar stool, if you will. And bass traps are generally placed into corners, and their function is to absorb some of the bass energy that's emitted from the speakers or the subwoofer and reduce the amount of reflected energy into the room. The less reflected bass energy in the room, the less severe the standing wave pattern becomes, and the less severe the peaks and nulls become with respect to magnitude. They're going to be there. We can't eliminate them completely, but we can reduce the amount of energy reflected back into the room, and that makes it easier to control them when it comes time to EQ the bass response.
We don't have to spend too much time on this, but can you drill down into the idea of standing waves a little bit more? I think that our audience can handle it, but I don't want to spend too much time on it. But what is a standing wave, and how does it directly affect the sound that you hear?
Sure. So the room itself is broken up into two sort of domains. The modal domain is where the room supports standing waves. The pressure domain is where it does not. When you get into the pressure domain, the wavelengths are so long, they literally can't form standing waves in the room, and then it starts transitioning into room gain. And I know that's something that I think you wanted to talk about later. But let's stay in the modal domain. So you have this direct sound coming out of the speaker or the subwoofer, and it strikes one of the surfaces in the room and bounces back. And this reflected sound collides with the primary sound waveform coming out of the subwoofer, and they will either reinforce with each other and create a standing wave peak, or they'll cancel with each other and create a standing wave cancellation, or a null, N-U-L-L. That's what we call them, nulls. The standing wave cancellation nulls are the hardest to deal with because they're literally acoustic black holes. It's just sucking energy out of the room at that point in the room and at that particular frequency. There's 5 types of standing waves. There's the front to rear, there's side to side, there's floor to ceiling, and then there's the more complex oblique and tangential. And if you think sort of like 3D pinball machine, you're kind of getting in the right area conceptually. So the standing wave pattern in a room can be very complex, but some of the most problematic ones we deal with are the front to rear, because that affects where you're sitting in the room. And if you're sitting in a standing wave cancellation, especially in the bass region, I mean, I've seen them so severe, it's a 25 dB black hole where there's no output at all. It's a very persistent and severe standing wave cancellation null. You don't want to sit there. There's nothing you can do about it. It exists in the room, aside from putting bass traps in and reducing the amount of reflected energy. But trying to EQ a standing wave cancellation null is not a good idea. If you throw EQ boost at it, it just gets worse. So that's the nulls are the hardest things to deal with. And I always attack them first with bass traps to reduce the energy reflected back into the room. And then secondly,
Reflected back.
yeah, and then secondly, don't sit there. I mean, I will literally tell people who I've looked at their room EQ wizard plot and they have a massive, suck out in the middle of the room at 45 hertz and it's severe. And I said, you don't want to sit there. We're either going to move the listening position or we're going to move the subwoofer because changing both of those will alter the standing wave pattern in the room and where these nulls are. And we try and find a relatively benign spot in the room that doesn't have a really severe and challenging standing wave pattern.
So correct me if I'm wrong at any point here, but since frequency waves they go up and down, right, like a wave. And it's to my understanding that the bass ones have longer waves and higher frequencies have shorter, more rapid up and down. This standing wave, does it only happen at a specific frequency, or does it happen like across a band of frequencies when it happens? Because since they're all different lengths, wouldn't only specific frequencies line up perfectly to create a standing wave?
Well, all the frequencies in the room can create a standing wave pattern. It just depends on what frequency they occur at and where they occur relative to the listening position. And that's a function of where the subwoofer is placed in the room and what the room dimensions are and where you happen to be sitting. For example, if you took a microphone and measured the frequency response at the listening position and then said, I'm going to move sideways 1 foot at a time and remeasure, well, the frequency response is going to change. And then say, I'm going to move forward 1 foot at a time and remeasure. That's going to change as well. I'm going to move backward. It's going to change again. And also, don't forget about the floor to ceiling one. If you've ever been sitting and stand up without otherwise moving, the bass response changes. Why? Your head's moving through the floor to ceiling standing wave pattern. So sometimes enthusiasts will even elevate the subwoofer, which again changes the standing wave pattern relative to your fixed listening position and your head, the height of your head. So moving around the room alters the frequency response that you're experiencing at the listening position. So obviously we can't change the room dimensions, right? That's fixed. And oftentimes the listening position doesn't easily move because it's defined by things like the other loudspeakers in the room, especially if it's an AV system. You've got rear surrounds, side surrounds, maybe overheads. But if it's a 2-channel system, you've worked really hard to get the equidistant triangle and everything, and you're like, oh, I really want to sit here, but it just happens to be a really bad spot acoustically. So maybe we can move the loudspeakers and sort of try and reestablish a more favorable listening position in the room.
So you mentioned room gain. How can people adjust for this in terms of if there's a lot too much, or even how can they use it to their advantage?
What happens with room gain is when the room transitions from the modal zone to the pressure zone, and that happens when the half wavelength of the room, you mentioned long wavelengths. As you go deeper, the wavelengths get longer. When the half wavelength becomes longer than the longest dimension in the room, and that's typically sort of the floor to corner diagonal along the room, that's the longest dimension. When the half wavelength exceeds that dimension, the room literally cannot support standing waves anymore. And through the magic of very complex mathematics, it transitions to a pressure zone. So you can actually move about the room, and the bass response below that transition frequency is actually quite uniform. And in a medium-sized room, that starts to happen somewhere in the 32, 33, 34 hertz range. In a larger room, the transition frequency is deeper. In a smaller room, it's higher. If you're listening in a really small room, I've seen it transition to room gain at 40 hertz. So it is dimensionally dependent, but at some frequency, the room transitions to a pressure zone. It doesn't support standing waves. And if you're running a monopole subwoofer, theoretically, room gain can add 12 dB per octave. It's a transfer function. We don't see that maximum value very often in real life because the rooms are not perfectly rigid vessels, right? You've got some flex on the windows, you've got flex on the walls, you've got maybe one permanent opening in the room. These things conspire against getting the maximum amount of room gain. But what we typically see is something along the lines of maybe 7 to 9 dB per octave of room gain. And that's free bass. It's a very significant rising response down deep. So, let's say we start showing room gain at 34 hertz. At 17 hertz, which is an octave deeper, you could be looking at almost 10 dB of additional room gain down low. And to make best use of that, our sealed subwoofers actually do the best job of that because we have engineered the roll-off profile of our sealed subwoofers to essentially be the inverse of the room gain transfer function in a typical size room. So as the subwoofer's rolling off anechoically, the room's adding bass from a room gain standpoint. What's the result? A flat line of deep extension where the subwoofer extends far deeper than it would in an anechoic situation, simply due to room gain. So I've seen our sealed subwoofers in a well-constructed room with a lot of room gain. I've seen some of our sealed submodels literally measure flat to 10 hertz or even 8 hertz. That's remarkable when you look at the quasi-anechoic curve of the subwoofer as we measured it outdoors. It might be 20 dB down at 10 hertz, and suddenly it's flat to 10 hertz in room. So you've got all this free bass that can enhance your listening experience and contribute to deeper extension in room.
You mentioned sealed. I know you guys also sell a ported subwoofer. Ported is a more traditional look. I think most people think of subs, think of ports. Can you just briefly go over the difference between sealed and ported and why your company decides to offer both options in almost every size?
Sure. So in a given family, we have a ported and a sealed model. Say, for example, in the new 5000 series, 5000 Revolution series, we've got the PB5000 PB ported box and SB5000 sealed box. The ported box variant is considerably larger physically, and that does contribute to increased sensitivity and efficiency just from the bigger cabinet. And it obviously is ported. It's a bass reflex system. The port tuning frequency with all three ports open is about 20 hertz. So we do tune our subwoofers very deeply. And what's the benefit of the larger ported subwoofer with the bass reflex ports? Higher output at the deepest frequencies, and that's just the physics of the design. So if the application calls for high output in the deepest octave, and let's just call that for this discussion purposes, maybe 18 to 36 hertz, that's the deep octave where LFE is strong on action and sci-fi content, and you have a large room, your playback level's high, you're trying to recreate this IMAX type experience or this high-end Dolby Vision type experience. Well, you need a lot of horsepower in the subwoofer channel in order to do that, and the ported subs are fantastic at that. They have a considerable maximum output advantage over their sealed counterparts. And for that purpose, they are more popular with the AV application in larger rooms, and simply because of their improved efficiency, sensitivity, and high output at the deepest frequencies.
This episode of the Occasional Podcast is brought to you by AudioQuest. All AudioQuest products, from the company's most modest parts to its most ambitious works of art, are thoughtfully designed to deliver outstanding performance and exceptional value, regardless of price. No matter how little or how much you invest, AudioQuest is made for you. Explore AudioQuest's award-winning cables, power products, and accessories at audioquest.com. Tired of audio reviews that sound like they were written by robots? Us too. For the last 15 years, Part-Time Audiophile has been an open revolt against boring. And this year, we're doubling down. We have a brand new look and a brand new name, but the same old attitude. Find us at pt.audio for all your turntable throwdowns and amplifier face-offs. Great sound meets good times at pt.audio. Today's episode is sponsored by Shit Audio. Shit Audio designs and builds audio components in Texas. Their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit shit.com. That's SCHIIT.com. So when we go back to room correction, and we were talking about all that reverb, there are a couple of things that I've found in the marketplace that help in terms of reducing those overall reflective rays that we were talking about that are kind of adjacent, you could say, to room treatments, because room treatments are the most like surgical kind of way to get it done. If you have a room and there's a lot of reflections in it, one of the absorption materials that is available, that if you're having a problem with the way the aesthetic looks, because none of this stuff is that beautiful all the time, I think that honestly, the one thing you can get away with the most is like bass traps, corner traps. Those you can kind of like slide in and maybe you won't see. But I want to let people know I don't have a specific vendor for this in mind, but they will print photos on some of the absorption panels for you. Some vendors will do this. And that, I think, if you have a place where a photo could hang and you're looking to just improve the sound a little bit, just make it a photo and put it up there. Now, I really appreciate your comment about diffusion as opposed to absorption, especially in the mids and highs. Very important to think about. And some of those like wood block diffusers, in my opinion, they look pretty cool. So there's something there also. But if you got a space for a photograph, you might want to try just printing whatever photograph you're going to put up or art, reprinting it onto this material, put it behind the couch. Ed, do you have any reco in terms of in between the speakers in front or behind?
Yeah, and actually to react to your statement, I've seen, really cool examples of this, family portraits, the family pet, a 1958 Corvette, hobby type stuff. It's just, you look around the room and you're like, wow, this is a well-appointed room, and these are really cool pictures you've got in the room, and they're actually room treatments. So that's it really does help with the lifestyle considerations, decor, and visual impact. So I do like that option. But to answer your question, again, you want to treat the primary reflection points in the room, and you can actually find those using a mirror and a laser pointer and a helper, where you're sitting at the listening position and you position the mirror strategically on a wall or the floor or the ceiling, and shine the laser on it, and then move it around until that laser hits the speaker in question, and say, okay, this is the center channel, for example, is easy. And say primary reflection points for the center channel are going to be here, here, and here. And obviously on the floor, you really can't put sound panels, so a nice rug helps. Sound panel on the ceiling, sound panels on the sidewalls. And to answer your question, yes, a sound panel on the back of the room and in the front of the room between the speakers is often recommended by experts in the industry who manufacture and sell these acoustic treatments.
Yeah, and you mentioned the word primary reflection. I've also heard of it called the first reflection, the first point of reflection. In a way, I kind of felt like you were saying, yes, it's good in the front, yes, it's good in the back, but what's supreme would be to get it at the first point of reflection to the left and the right. I don't want to paraphrase what you're saying, but would you agree that that's also great or of more importance?
I would say the critical ones are the ceiling, the floor, and the side walls. Those are big. The rear wall behind you is going to be a reflection point as well. Of course, you're going to be losing energy as the frequencies travel through the room. So those are the big ones. A bare ceiling is disastrous from a reflective standpoint. It's just as bad as bare walls, and a lot of people don't think about it. It is difficult to treat the ceiling and make it look nice. So I would throw that out there as sort of a concession or a talking point. In my high-end theater room, I do have the ceiling fully treated. It's not attractive, but it sounds amazing. So, is my living room, family room packed with acoustic panels? No. Do I care? Not really. Why? Because it's not as critical of a listening room for me. I've got a throw rug, I've got curtains, I've got upholstered furniture, and I'm like, okay, it's good enough. I'm just streaming up here watching the news or whatever. So sometimes it's really a priority to the enthusiast. How far am I going to take room treatments, and in what room am I going to take room treatments? And what other rooms am I willing to concede a lack of room treatments to lifestyle and decor aesthetic considerations? So it's always a balancing act when you're talking about room treatments. They're not for everyone, but if it's a high-end system and it's important to you and it's your primary listening room, I think it's absolutely worth doing at least some level of room treatments because it really can transform the room.
So this is a two-parter, but I have a point to it. I want to know if there's any way that you can think of to have good bass in a room, but not have it bleed to the apartment next door. So for our listeners who live in an apartment, is there any way to like get a sub, have it sound great in your system, but not have it disrupt? We'd have another room in your house, but apartment people have quite a big problem. And is there any relation to that if you have very hard feet that make it connect to the floor, or if you bring it up, put rubber underneath it so it's not directly coupled to the floor? Is there any relation to those two things, or what's the benefit of having rubber feet or really those pointy spikes through carpet?
So there's two components to this. Let's talk about the acoustic one first. Bass waves are notoriously difficult to stop. They pass through everything. You've probably been sitting in your house and heard some guy drive down the street with a subwoofer booming. What do you hear? You hear the bass. You don't hear the mids and highs. You hear the bass. Why? Bass waves go through everything. They're very persistent. Yes, they can reflect in your room, but they also penetrate barriers much better than mids and highs, which are comparatively much easier to reflect. So the very deepest frequencies that are sort of the most powerful and persistent with the longest wavelengths, those are going to travel through the building and reach other occupants, like you said, an apartment complex or a townhouse, or in the same home. Somebody in another room, hey, I can hear that subwoofer running. That's almost impossible to stop because of just how persistently strong bass waves are acoustically. But let's set that aside and look at mechanical energy that's transferred to the flooring. If you've ever been in a home with a wooden floor over an open space like a basement, so you're down in the basement, you got kids in the house, and they're running around and they're jumping up and down. What do you hear? The floor booming. And you're like, hey, knock it off up there, right? Well, that floor is acting as a huge transducer, and it's actually resonating. It's moving up and down. And so what happens if the subwoofer couples to the flooring mechanically, and that flooring can move like a big transducer, then the subwoofer excites the resonance frequency of the flooring, and you get what's called floor boom, and this floor boom and flex creates its own sound, and it unfortunately happens to be right in the bandwidth of the subwoofer. So it's sort of this vicious cycle. The subwoofer creates bass, the floor moves up and down and resonates, the floor creates boom, which in turn adds some buzz and rattle in the room, and the bass sounds sort of sloppy and boomy and resonant. What's the solution for that? Well, we want to decouple the subwoofer from the flooring surface. And you can do that using a product like our SoundPath subwoofer isolation system, which are much larger feet that have a different durometer over the rubber, the durometer that's quite a bit softer, and it allows decoupling of the subwoofer from the flooring, so you're not transmitting mechanical energy to the flooring. You've sort of short-circuited the floor boom and floor resonance and buzz and rattle in the room. And that does have its own component that's can be annoying to occupants in the house or your neighbors in adjacent apartments. So I would say, again, you can't get rid of the acoustic aspect of it other than turning down the subwoofer. But you sure can attack the mechanical element of it by isolating the subwoofer from the flooring. And just so it doesn't sound like a commercial, like like Nick said, you can also do this with isolation transformers or pads rather, where you put the subwoofer on a big isolation pad. That can perform pretty much the same exact function. They're a little clunkier in appearance, visually and cosmetically and aesthetically, but they do the same thing as our isolation feet. Now, I will add that if the subwoofer is on a concrete floor, well, if you stomp your foot on a concrete floor, what happens? Nothing, except you get a sore foot. Concrete floors do not transmit mechanical energy in the bass bandwidth, at least not appreciably. So if the sub's on a concrete floor, you can skip that type of isolation product because you just don't need it. But if it's on a wooden floor over an open space, and if you jump up and down on that floor and you get obvious floor boom and resonance, then yes, it's a great candidate for the subwoofer isolation system or an isolation pad.
Do you have any opinion on, I mean, I talked briefly about the idea of spikes. Would you or recommend a pair of spiked carpet spikes on a pair of floor standers, for instance? Let's talk about like more of the 2-channel, like a big floor stander, the option for carpet spikes. Would you recommend, and what application would you like it? Also, any opinion on spikes on components? Because sometimes they take it and put it on the component level too.
Oh, well, the first thing to recognize about spikes, I mean, people call them carpet spikes. You can put them on hardwood flooring too if you have a disc that protects the floor. But the way spikes work, the concept is different. You're taking that footprint of what would otherwise be like a large isolation pad or a large isolation feet. So in those cases, we're absorbing the mechanical energy and preventing it from reaching the flooring. So it's an absorption system. In this case, we're taking the footprint of what would normally be a larger foot and we're making it so tiny that the ability of it to transmit energy is limited simply because it's a very tiny connection point to the floor. So that's how that works sort of from a technology standpoint. Do they work on carpeting? Sure. And also hardwood floors or other types of floors if you protect the floor with a spike. But am I a fan of them? Not as much as I am isolation feet, but they do work. And I would say using them on components, I mean, if they're sort of solid state components, I think it's a little bit of snake oil. But if it's a turntable, absolutely. I mean, we've all heard a turntable that's too close to loudspeakers or the subwoofer. And again, you've got the combination of mechanical energy and acoustic energy. It starts exciting the turntable stylus, and all of a sudden you get this massive feedback through the room. That's strictly due to a transmission of bass frequencies acoustically and mechanically that affects the turntable the stylus starts wiggling around, and boom, you've got a feedback loop that goes ballistic very quickly. So I am a big proponent of isolating the turntable from vibrations. And I've seen, high-end feet with gel in them, or to your point, sort of the spike feet. Both of them work pretty well. Neither of them prevent the acoustic aspect of it. So you don't want your subwoofer or speakers too close to the turntable because, again, literally acoustically, you can create a feedback loop as well.
I appreciate that. Shout out to my turntable folks. We've done a lot of stuff on turntables. We did a lot of stuff on turntable carts specifically so far this season 2 on turntable carts. And I appreciate the tips because I think of all the components.
Absolutely. And vinyl's, been making a comeback over the last 15 years or so. And we do get our share of customers who purchase one of our subs and reach out and say, hey, my turntable's making bad noises and I'm getting feedback loops through the system that I never had before. One sense, we're a little bit proud of that and saying, yeah, we've got deeper and more persistent low frequency energy that's emitted out of our subs, but yes, that's going to exacerbate the problem with your turntable. So move it farther away and isolate it, and that generally makes the problem go away. And you can actually put in an infrasonic high pass filter as well in the subwoofer. We do have that function in our DSP menu, and if you sort of cut out that deepest octave, which generally there's not much music content there anyway, unless you're listening to maybe acoustic pipe organ, but if you want to sort of cut the response a little bit below 20 hertz, that can help prevent turntable feedback as well.
So I've actually discussed this so much on the podcast this season as well, but we've talked about 20 to 20 hertz being the listening range, and I've asked many of the interviews, does sonic information outside of the 20 to 20 hertz affect what we hear on the inside that we know we can hear 20 hertz. Obviously, it's lower if you're older. That's the hearing loss bit. But in this question, I'd like to ask for you, does information below 20 hertz affect what we hear in the audible range on the low side? Because a lot of that conversation revolves around what happens on the high to the mids where we hear voice. But let's talk about the low end rubble. Some of your subs, I believe they might even be rated below 20. What does that information mean in terms of what we hear and how the rest of the frequencies response reacts to it?
Well, first I'd like to say it's actually a bit of a myth that we cannot hear frequencies below 20 hertz. We can. That audibility is what we call threshold dependent, meaning it needs to be louder in order for us to perceive, for example, 16 hertz or deeper. We can hear it if it's loud enough. So let's set that aside, but I did want to mention it. But even if we can't hear it, we can sure perceive it. And if anyone's ever been in a large cathedral that has a legit acoustic pipe organ in it with the 32-foot stops, and a lot of horsepower behind it in terms of the air pump, that 32-foot stop is 16 hertz. And when the organist hits that 32-foot stop, it creates a very obvious and palpable pressure, thickness, and sensation in the air. Sometimes it makes the hair stand up on the back of my neck and on my arms because I know what it is and it's cool. When I look around the room at other attendees and they're having a similar reaction and they're like sort of uncomfortably looking around and their eyes are shifting and they're like, what is that? And it's this palpable pressure, thickness, and solidity in the air. That is 16 hertz. We can feel it. We can perceive it. We know it's there. It may not be easily audible, but it sure makes a difference in the listening from an experiential standpoint. And the same thing holds true on the AV side. One of the ones that springs to mind for me is the Flight of the Phoenix remake with Dennis Quaid. There's a scene where the plane's flying through the dust storm, sandstorm, before it crashes. And I've looked at the spectral content of that particular scene. There's a whole bunch of information in there below 20 hertz. 12 hertz, 13 hertz, 15 hertz, 17 hertz. It's packed with deep content. And if you're playing that scene at a fairly loud level and the subwoofer can dig that deep, what you get is a very obvious sense of changing infrasonic pressure in the room. It's sort of like a buffeting, a changing pressure, changing solidity and foundation in the room. You can actually feel it's something we call it pants waffling. You can literally feel the very deep frequencies sort of waffle your shirt a little bit or waffle your pants legs, pants cuffs. You can't hear it, but you sure can feel it. I've even gone so far as to retune the subwoofer to 20 hertz instead of 16 hertz and play that scene back to back. And a significant portion of that sensation goes away with the 20 hertz sub. It's still there, but you tune it back to 16, and which means you're getting in-room extension to maybe 12 or 13 hertz with room gain. Bam, it comes back. And you're like, wow, that's kind of a cool sensation, and it really does add to the sort of tension and menace and mood that tells you are literally in a plane that's being buffeted infrasonically, and it's sort of pressurizing the room. It adds to the realism and tension in the scene.
Wild, man. That's wild. I love it. I love it. Tell me a little bit about polarity and phase and that 180 switch on the back of the amp.
Okay, so that people used to call that polarity, but it's actually not. Back in the day, you would see it would be labeled, or rather be labeled phase, and it's a 0 to 180 switch. Well, it's not a phase control at all. It's a polarity switch. It's either 0 or 180. And so what does the polarity switch do? It literally reverses the entire polarity of the electrical signal being sent to the subwoofer as if you had swapped the speaker wires. And we do have it in our subwoofer menu for very isolated reasons. The one that springs to mind the most is there are some brands of loudspeakers that are built with what we call reverse acoustic polarity. A couple of European brands spring to mind, and most loudspeakers are built with what we call positive acoustic polarity. And if you put a signal on the woofer, it pushes out. If you put a signal on the woofer, some of these are built quote unquote backwards. They have negative acoustic polarity. They sound exactly the same, but if you try and integrate a subwoofer with them, the subwoofer is literally 180 degrees out of phase with the loudspeakers. That creates all sorts of integration problems that wouldn't otherwise exist. And people will come to us and say, hey, I can't integrate your subwoofer with my speakers. It sounds horrible. There's like cancellation over the bass ranges. What's going on here? And I say, well, what brand and model are you running? And they tell me, and there's a little red flag goes off in my head. And I say, let's do a quick test with a battery on the back of your speakers. Touch a 9-volt battery to the terminals, positive to positive, negative to negative. What direction does the woofer move? Well, it pulls in. Okay, your speakers are built with negative acoustic polarity. Flip the polarity switch on the subwoofer to negative. Boom. Now it's in phase with the speakers, and everything's right with the world. So that's really the only application for the polarity switch. And it works beautifully when you need it. Most of the time, you want to leave it set to 0, which is, again, positive acoustic polarity. Now, the phase control is a totally different animal. We do have a true phase control that's frequency dependent. And what that does, it delays the signal being processed through the amplifier. And we have a very granular control. It's 1 hertz increments. So you can literally alter the signal being processed through the amplifier with the phase control 1 hertz at a time. So you've got 0 to 180 in 1 hertz increments. And what's the benefit of that? There are times when you want to delay the signal being processed through through the subwoofer, so it can integrate with loudspeakers if they're placed in different parts of the room and they're reaching you at different times. And say, well, wouldn't it be convenient if I could delay the signal a little bit being processed through the subwoofer? And that's essentially how the phase control works. It is frequency dependent, but it is sort of an all-pass filter, and it has a wide operating bandwidth. So that's very different than a polarity switch, and I wanted to make the distinction between the two.
That's awesome. Ed, anything that you'd like to kind of address right at the end of the show here? Anything that's been on your mind? Anything you've read, been thinking about in terms of audio?
Oh, I think we were going to talk about auto EQ, weren't we, Nick?
You know, I think it does factor into a lot of the conversations you've already had just about how your speakers and subwoofer interact with the room, and then the value of DSP, digital signal processing, and processors in shaping that in-room response. Because I think the DSP, as far as subwoofers go, there's a lot of this like tractor pull mentality. Well, how loud can it play? How low can it go? And obviously those are critical factors when it comes to subwoofer performance, but how it interacts with the room and how you can adjust its output to really complement your room and complement your speakers and blend it seamlessly, I think is one of those things that people don't learn until they start trying to do it with the subwoofer. And there's a sort of overarching theory that subwoofers are the hardest thing to get right, and bass is the hardest thing to really get dialed in. So we do have a auto room EQ feature coming out on some of our newer models of subwoofers, the 5000 Revolution and 17 Ultra Revolution. It'll be available by early in 2026, and this is really just a simple automated process that really will help you achieve that even in-room response, so you get a broader sweet spot where all those peaks and nulls and the variables that Ed was talking about really get balanced out. So we can go as deep as you want as far as the technical. I think you can tell with Ed, but it's really about just simplifying the process that can be extremely tedious and getting you that better performance. Whether it's 2-channel or home.
Yeah, I mean, we were talking about standing waves and peaks and nulls in the room, and how to control that with bass traps, and how to control it by moving the listening position or the subwoofer around. But at some point, you reach a state of diminishing returns, and you're like, I've done everything I can. I've got bass traps in place. I've optimized the location of the subwoofer. I've optimized the location of the listening position. I still have an imperfect frequency response. Well, of course you do. It's in a room. And that's where equalization comes in, and the auto EQ feature that we're working on. And essentially, you connect the microphone to your smartphone, and it runs off the app, and the microphone is placed at the listening position, and you run the program, and it measures the frequency response of the subwoofer at the listening position where you're sitting. And it then applies through very sophisticated DSP and filtering a set of equalization filters. I think there's 16 PEQ filters in there, so it's quite granular in terms of filter resolution. And it builds these EQ filters to flatten the frequency response of the subwoofer at the listening position, because in the end, Brian, frequency response is king. If the subwoofer has a flat frequency response where it does not overemphasize or underemphasize or attenuate any portion of the bass spectrum, it will sound more accurate to our ears. That's the goal. We want the bass to sound accurate, and that means the frequency response is as flat and linear as we can possibly make it. So we attack it with bass traps. We attack it with placement of the MLP and the subwoofer, and then we attack it with EQ. And the EQ is the sort of the final step, and it results in a much smoother, flatter frequency response from the subwoofer, which in turn, subjectively, sounds much more accurate to our ears. And again, that's the whole goal, right, of music reproduction in our homes. We want accuracy. We want it to sound lifelike. We don't like boomy one-note bass. We like tight, linear, smooth bass over the entire bass spectrum, so it sounds more like music, or in the case of a movie, what the mixing engineers and director intended. We just want it to sound more accurate, and that's where auto EQ comes in, and it does a remarkably good job at that.
I tell you, when I hear bass, like you said, there's two qualities of bass that you've mentioned that is rare, and when I hear it, I love it. One, it's the start-stop thing. Okay, I used to have an uncle, and I hear this all the time on high-end systems at audio shows. They nail the bass right, even though a lot of times the room is hard. They still get the bass awesome. It happens. It doesn't always happen. It's rare. But my uncle used to have a sub with a wood floor, and it would just play, and I would be shocked at how beautiful it sounded. Like I could really just hear the vibration of the speaker driving, and of course the way it blended in, and it was natural. But just like the start-stop motion when it's done right is beautiful. But also, when a bass player plays the bass and they go up the scale, or you do, heaven forbid, a frequency sweep, right? And it just stays even as it rises, incredibly rare out of the box. You take a speaker, you set it up, you do a bass frequency sweep from the bottom to the top or the top to the bottom, and you hear that. For it to be perfectly even across is incredibly, I don't know if I've ever heard it out of the box straight up without anything. So when that happens and it's like that bass player goes up the scale and every note feels like it has the same impact, absolute beauty.
Exactly.
So I agree. If you nail that stuff down.
It's a magical moment when you hear it, and that is achieved through, again, attacking it acoustically, through placement and positioning, and through the DSP auto EQ. And the combination of those three tools together can get you pretty darn close, Brian. And again, frequency response is king. When that is flat and linear, it will reproduce the bass in the most authentic and accurate and natural sounding way. And you're going to react to that and say, oh man, like, I can hear the nuance of the kick drum and the tom-toms and the upright acoustic bass, and I can hear the pluck of the strings as he's moving up and down the frets, and it's just magic. And when that goes away due to floor boom or standing wave peaks or nulls, you lose that sense of magic in the room, and that's really what we want. We want to be transported by the music in our minds to another place. That's the whole point of high-end music and being high-end audiophiles. We want to be transported. We want the musician to take us to the place where they created that music. And that's not possible unless your system is as accurate as it possibly can be, and then the magic happens.
I also like to think of it as bringing them to us, creating the illusion that the person is in the room with you. You can go places. I like that idea that it's like, maybe the idea of fantasy, that we are escaping to somewhere else. But also you could argue it's like bringing them right there. And I think I have to credit DeVore with this very abstract idea. But it's like we're bringing dead people back to life. Someone who is no longer with us. This is the thing that I've been trying to bring up on the show. I haven't figured out how to shoehorn it in, but I do want to bring this up. Video will never be able to convince us, as it currently stands, that something is right there in front of us as well as we can with audio at this point. When I think with a really high-end system, you can trick your ears into believing a person is singing to you much better than you can, I believe a person is standing in front of me. And that to me is a part of the magic of audio.
It is. That is the magic trick. And there's not just one thing that gets you there. It's a combination of things. And you attack it using the tools we have in the right order. And then you achieve that nirvana, that aha moment, and the performers in front of you. And that is that magical moment.
Nick, Ed, thank you so much for coming on the show. I appreciate all your insights and all your help. I wish you guys a great year, and I will see you at Capitol.
Thanks, Brian. Been a pleasure, and we really appreciate you having us on the show.
Thanks, Brian. And Ed, sorry I had to carry you this time, but
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes PartTimeAudiophile.com, The Occasional Magazine, the PTA Newsletter, and Audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter. Executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE Studio monitors. AI songs produced by Udio.com. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.